So now let's hear the first talk, which will be, the title of the first talk will be SIMCoD, a virtual and augmented reality digital platform for research on immersive, multimodal, collaborative, and remote simulation. Patrick?
Okay, thank you. Good morning, everybody. As it was just said, I will present you the SIMCoD project, which is the acronym of Immersive, Multimodal, Collaborative, and Remote Simulation. SIMCoD project is a platform of digital, that means based on a large research program on virtual and mixed reality for collaborative application. We have support to deploy for the deployment of 3 equipments, 2 large virtual and mixed reality systems. The AF system is just finished to be installed, and it is the picture at the right is presenting you this system. It's a very large system with multi-sensory and multi-user capacities with several large screens around a floor glass of 13 meters, all within an acoustic rooms with 3D audio and haptic capacities. Anyway, the same kind of system will be installed at CEA list, and it will be, these 2 systems will be connected with a third system, which is oriented to autonomous vehicles at Axis EUF lab. Well, my presentation will first focus on some concepts about virtual and mixed reality and collaborative virtual environments, and I will try to, in a way, present in a way the 2 other speech. And after that, I will focus on the second project, its research programs and the demonstrator in progress. And finally, I will conclude with some opportunity for the future. Virtual reality is a kind of system which aims to have multisensory immersive interaction with numerical data, also named virtual world. And the keywords of such system are immersion, realism, real-time feedbacks, and natural or intuitive interaction. So that is one of the definitions of this domain, but we have 2 remarks to do. The first one is that the virtual worlds are not always realistic, and a typical example are the scientific application. And the second remark is, conversely, we required the interaction need to be realist, at least to prevent sensory motor incoherency and cognitive stresses. Anyway, mixed reality is the extension of the virtual reality for managing that Milgram calls the virtually reality continuum with the scheme at the right. So in that case, we will mix real and virtual objects to interact with them via the same sensory motor capacities. If you have a look about an interactive scheme of what is virtual reality, we can say that it is an interaction between the real world, the real world with humans, and the virtual worlds with virtual objects and also humanoids via human avatars. These human avatars are not only a virtual representation of the human, we mean with virtual hand, laser beam, and so on, but have also to manage all the interaction with the virtual world. So all the feedback and also input events. Now, when you extend the system to mixed reality, two kinds of entity are applied, the real objects and the object avatars. And this time, these object avatars has a virtualization of the real objects, but must be also fully operative to interact with the real objects. Now, what is a collaborative virtual environment? Actually, there is three kinds of collaborative virtual environments. The first one, and the more popular, is probably the distant collaborative virtual environment, where n real worlds are occurring a set of human avatars and object avatars. It's typically the case here. A set of humans in separate worlds, set of objects in separate worlds are occurring different kinds of subset of human and object avatars. These human and object avatars must have an homogeneous representation to facilitate the activity, but on the other hand, must be identifiable according to the location of the different humans and different objects. This scheme didn't provide any hypothesis about the architecture, I mean about the implementation of the system. But the main importance point is it's about the communication between real humans. This communication may be mediated, I mean with classical multimedia system, audio, video, chat, and so on, but also may be virtually incarnate via human avatars. And in that case, we need to control the coherency and the synchronization between these two channels of communication. A second kind of collaborative virtual environments are co-localized one. This time there is only one real world, but different groups of real humans have to interact to cooperate. First, within a group, you may have a same perception of the scene, for instance, with pseudo-stereoscopy. And in that case, the control of the application is organized with a master-slave structure. That means one master gives all the control on the perception for all slaves, users. But you may have also a system where two groups of real humans have a different perception, and that is the case with the health system we have at LIMSI, with multi-stereoscopy and people who share the same workspace. In that case, the control of the application needs a supervisor process, and it's less critical than in distant collaborative virtual environment, but it's necessary. So, for co-localized collaborative virtual environments, you have no mediated needs because direct interaction between humans in the real world, but virtual incarnation are probably necessary in some case when the user focused are very different. And the last situation is a situation of teleoperation. It is close to a severe collaborative virtual environment with distant situation, but in that case, one group of humans cannot interact with the other world without a link with the virtual world to have a control on the real object of the other world. So in that case, you may have mediated communication, but also virtual incarnation, and it's typically the case for tutoring application. While one of the critical points will be the sensation of telepresence. Okay, it's clear that the presentation is a little bit short. So the main topics of the SIMCoD project is collaborative tasks in virtual and mixed reality with virtual and mixed reality technologies, and I focus my presentation now on two demonstrators. The first one is oriented towards the design and assembly chain, and it's involve two partners, LIMSI and LIST, with different contribution. And an example of such contribution is the video here. So that is typically a result of the PerFerV project, and the work is on human avatars to control for assembly task with actually two guys. Presently there is only one, but next images show you you have several people, and you have also metaphors. Not here. You have also metaphors of contacts here, and here you can see via virtual humans how we can plan an operation on a complex manufacturing industry. So the shame of this first demonstrator is a restriction of the previous shame about co-localized CVE. It's only VR-based oriented. There is no humanoids, and it's oriented toward tutorial task. There is several challenge how to manage double stereoscopy versus avatars, how sharing haptic device for tutorial activity, and how to manage interdependency and direct versus command for multimodal interaction. That is a setup, and an example of the interaction we may have is this one.
Sélectionnez ce siège.
So you have speech recognition and gesture recognition to interact directly with a virtual scene.
Rotation suivant Z. Tournée de moins 90 degrés. Déplacé suivant X-. Déplacé de cette distance. Translaté de cette distance.
So the gesture recognition system can manage
déplacé suivant Y-.
Double hands gestures.
Translaté de cette distance. Déplacé suivant Z.
And tracking, voice recognition and gesture recognition are merged in a supervisor of the multimodal interaction.
Rotation suivant cet axe. Tournée de moins 45 degrés. Déplacé suivant cet axe. Translaté de cette distance.
Okay, actually this demo is an example of what we want for the future. We want to have two guys like that which interact together with a virtual scene, and we will share an haptic device just like this one presented here. The second demonstrator is oriented toward telesupervision of an autonomous car. It involved LIMSI and EEF laboratory. Its topics are augmented virtuality and autonomous vehicle. An example of mixing the teleperception of and the virtuality is presented here. Here a guy is interacting with a virtual scene and a real scene. You have here what he can perceive in the real scene, and the both representations are merged, virtual and real representation, and merged in the same cave-like system. So that is an indoor example of the control we want to have for the PCAR cars, an autonomous vehicle. So that is just a pre-demo of what we will obtain in the next demonstrator. The objective is, of course, teleoperation with a mixed reality within a cave-like system, which is very original, no humanoid, and the task is a remote driving situation. The challenge are the remote control with a mixed reality system, multi-sensory remote perception, and so on. For the future, we are candidate to the free auditor of the Partage National project, and we are developing contact with CoSpace, a European project. We are involved in V&AR association, and we will have the inauguration of our system in spring 2010. It's the last slide. And our focus is today to evaluate our CAV, collaborative virtual environment interactive paradigms, extend this use to other applications which required collaboration between experts, for instance in bioinformatics, and also to analyze how the combination of several collaborative virtual environment situations can cooperate. Thank you.